Right, so for part C, I've just decided to put the image that you can see it. I don't have to keep scrolling up and down. Part C, let H and K be the midpoints of OE. So H and K would split O this part, so that's equal. So that's the same really. And then this would be the same as well from F to K and F to C. Right, so this just split them. Part CI, show that HK is lambda C and FE is mu of C for some mu and lambda belonging to R that is not 0. Okay, so that's pretty much saying find HK in terms of C and find FE in terms of C as well. So let's get into it. HK, vector HK, how do we solve for that? Well, if you want to go from H to K, I'll just draw the vector right here, H to K, right there with the arrow going to K. So if you want to go from H to K, you can go from H to O, so H to O, up here, O to C, right there, and then C back to K. Right, we know that HO is half of EO, so we can write that down, half or negative half of OE if you prefer. And then OC is just vector OC, but I'll just write it there. CK we know is half of CF, so you can write that down, half of CF, because it splits them into two. Okay, OE, as we've already found in the last video, is negative half of half A plus half C. And then OC is just vector C, I'll bring it right here for a little bit. And then half of CF, as we found in part A, CF is negative C plus half A, and there we go. So you just expand your brackets and then simplify them to get what HK is. So let's get into it first. And we should get it in terms of C only, because the question says it's lambda of C, so there's no A. So if you did everything right, this part should only have vector C in its expression. So let's get into it. Half, that gives us 1 on 4 times vector C. Okay, so that's what HK is. We haven't finished the question, we need to find what FE is as well. So let's get into it. FE. FE, how would you go from F to E? Well, this is actually quite simple. It's F to A to E, F to A plus A to E. And F to A we know is half of OA, so we can just half that. Half of OA, which is A, and AE is half of AC. If you want to go from A to C, we know it's negative A plus C. So that's half negative A plus C. And that's it, just add them up together. The A cancels out, which is quite nice, but then you have half C left over, which is FE. Okay. And the good thing is they're both in terms of C, which is what we need. There's no more A, and that's quite nice. So we can tell that lambda is 1 on 4 and mu is half. Let's move on to part I. Okay, what does I say? Give reasons why why triangle HXK. So this triangle right here, I'll put in red. HXK, this small triangle, is similar to triangle EXF, so the slightly bigger triangle. Right there, this blue triangle, why? We need to prove or show that these two triangles are similar. Vector method is not required. Okay, so we can use geometry in this case. We know that HK is 1 on 4C, and FE, right here, so this vector, FE, HK, FE is half C. They are parallel to one another. So HK is parallel to FE because if you multiply FE by a half or if you multiply HK by 2, you get the other. So that means they are parallel. They are scalar multiple of one another. Okay, so we know these two are parallel. We're going to use that to help with our geometry. Okay, right. If these two are parallel, so FE and HK, that means this angle right here, so I'm about to show you that green angle right there is equal to this angle, so this part F, so I'll write that down, angle over here FEX is the same as KHX, angle KHX, and you can say alternate angles, right? Of course, we know that's one of them. We can also show that these two are the same. Well, they are parallel, so these two angles right here are the same as well, alternate angles. So angle EFX is the same as angle HKX. Alternate again, alternate angles. And then angle FXE and HXK. So this last triangle right here, this last angle right here, I mean, are the same because they're equally opposite, okay? Or vertically opposite angles, right? FXE is the same as HXK, and because they are vertically opposite angles, right? So we know that if three angles are the same, and if you remember from your coordinate geometry in year 11, if you prove that three angles are the same, that means those two triangles are similar. Therefore, triangle, so we'll write what they want, HXK, what the textbook wants, is similar to triangle EXF. And that's pretty much it for part double I, okay? We don't need to use vectors at all. But part triple I, we do need to use vector, right? Okay, so for part triple I, we need to show that, we need to prove that OX right here, OX is twice as long as XE. Okay, it's a hence question. We need to use the answer from the first two parts to help us solve for this part right here. So let's get into it first. Okay, so we know that HK, so vector HK was 1/4 of vector C, and FE was half of vector C, which means that HK in the ratio to EF is 1:2, okay? So if HK was 1, FE would be 2. And because these two triangles are similar, using part double I, we can also say that HX, so H to X right here, with a ratio to X to E, they are the similar sides. You can so here's a nifty trick. HX, these two sides, the similar side would be EX, so the first two letters as well. Okay, so XK would be similar to XF, EF would be similar to HK, right? And that would also have the ratio 1:2. We can use this to help us to write it in terms of vectors. So that means XE right here, the magnitude of XE is 2/3 of HE, right? So how does that work? How does that work? So let's get this line segment first, and I'll show you how this came about. This is H, this is X, right there, and this is E. We know that HX is 1, we can call that 1, XE length is 2. So therefore, XE would be twice, or 2/3 of the entire thing, okay? So it's 2/3 of HE. So that's how we got into this. Okay, of course, we can write this in another way, and that is HE, we know, is half of OE. So we can write HE as half of magnitude OE. That has been told in the question. H is the midpoint of OE, right? And of course, if you multiply them together, you get 1/3 magnitude of OE. So magnitude of XE is 1/3 of OE, okay? So this part right here, 1/3 of the entire part. Okay, we're almost there, we're almost there. Now I'll draw this line once again. Okay, this is O, this is X, and this is E. Okay, XE is 1/3 of OE, so XE we'll call that 1. If OE, the entire length is 3, that means this would be 2. So that leaves us with OX with a ratio to XE, which is what we need, OX ratio to XE. OX is the 2, and EXE is the 1. And therefore, we've proved part triple I, C triple I, okay? And that is how you solve this question. So it is quite long, quite difficult, guys, but at the end of the day, hopefully this should help you finish your chapter review in your chapter 2. Thanks for watching, guys, and I'll see you in the next video. Thanks for watching.